Hey everyone! Have you ever tried to learn how to code but got stuck? In my new Python programming class, we're going to break that loop. This course is primarily focused on people who are complete beginners, so don't worry if you don't have any background. This course is different than other courses because we're going to teach you to think like a programmer and solve problems like a robot. So let's get started. Hi everyone! So welcome to the first video where we're going to actually start learning some of the more fundamental aspects of programming. So in the last couple of videos, we ran our very first program, which was print hello world, and we learned a couple of things about Jupyter Notebooks, a couple of common pitfalls, and just some of the functionality of Jupyter Notebooks. Now that we've learned that stuff, we're ready to jump into our first problem set. Now, the way that this course is going to be structured, we're going to actually be using problems to teach us the concepts. So a lot of programming courses and tutorials will start from the very basic concepts and then use examples as illustrations of those concepts. We're going to flip that on its head. So we're going to try to solve a problem and then illustrate some fundamental programming concepts in line of trying to solve that problem. So why is this useful and how can this help us solve it? So that's the way that I'm going to approach everything in this course. And hopefully this will be helpful for you to understanding programming rather than just learning it. Actually understanding why something might be useful and why we might want to use it ourselves. Starting there, the very first problem we're going to try to solve is solving the quadratic formula. Now, I know this might sound a little scary, especially if you never liked math, but don't worry, this isn't going to be a lot of math. We're not going to be doing any algebra. We're not going to really be doing anything like that. The only thing that we're going to do is just talk about what the problem is and use programming to solve it for us without knowing any algebra. So that's going to be our goal going into this. So here you see there's a lot of text here, and this is included in the notebook that you'll see that's included with the course as well. But the first thing I'm going to talk about is what is the quadratic formula. So quadratic formula you probably learned when you were in high school. The quadratic formula is a formula and it's nasty and long and a lot of people had to memorize it. And what that formula does is it tells us the roots of a quadratic equation. So a quadratic equation is something that looks like this. Basically, it has a squared term, a non-squared term, and then a constant. So it's something like ax squared plus bx plus c. Now, a lot of people start zoning out here. So this is the most amount of algebra that we're going to use throughout all of this. But this is just to give you an idea of what a quadratic equation looks like. And what a quadratic equation looks like in terms of a graph is going to be a parabola. So it is U-shaped or upwards, backwards U-shape. It could be also flipped upside down. But this U-shaped curve is what a parabola is. And it's the graphical representation of this formula. What we're trying to do is we're trying to find the roots of this equation. So what are the roots of the equation? This picture just is a very good illustration of what the roots are. The roots are where this parabola is going to intersect with the x-axis, which sounds like, why is that useful? Instead of talking about an intersection with the x-axis, we might just want to consider it as where y is 0. So usually what we're looking at, what we're interested in is y. To make this a little bit more concrete and rather than it just be a parabola, let's try to talk about fun in terms of hours of math. So hours of math is going to be our x, fun is going to be our y. And imagine this is the formula that we have, right? So we have fun in terms of hours of math. And we might want to know at what point are we going to start having fun and at what point are we going to start not having fun? In other words, at what point is fun going to be positive and at what point is it going to be negative? So when does it turn from fun to no more fun anymore, right? That might be useful to know. And to solve that, we need to know what the roots are. So said in another way, if we know when the fun is equal to 0 and that it follows this equation, whenever fun is equal to 0, that's when it's turning from positive to negative. And that's why we might want to know the roots of the equation. This can be used for pretty much anything. I'm using fun in hours of math, but you can use this for a lot of different things, right? So knowing these roots could be useful because it can tell us what the turning point is and things to optimize for, right? So if you're talking about revenue, it might be useful for you to know, or profit rather, so revenue minus cost. It might be useful for you to know when you're actually profiting and when you're not. To do that, if you knew that your profit is going to follow a quadratic equation, like this one or this one, it has a parabola shape, knowing where the roots are will tell you where your break-even point is, right? Where you're going to stop or start profiting beyond that point. So it's very useful information to actually know what these roots are. And I think it's a little bit lost when we talk about it in our algebra courses in high school. It's like, why do we even want to know what this root is? That's why you would want to know. It's pretty much where things are going to go from positive to negative or negative to positive. And that can be useful for a whole bunch of different tasks if we know it follows this equation. Okay, so That's the first thing of why would we even want to know this and what a root is. The old way, the way that you learned in algebra, is a formula. There is a long, nasty formula based on these letters, the A, B, and C, that you can plug into that formula and you will get the numbers that are going, the x values here, the negative 3 and 5 in this case, that are going to be the roots to that equation. However, first of all, that's something you probably don't remember. And second of all, we said we weren't going to be doing any math and we're not going to try to actually solve this. We're going to try to take a different approach. The math way of solving this is a theoretical approach, and there is an exact solution, which is a great thing, right? And don't get me wrong, I love math, but I know that a lot of people who, the reason they don't want to learn programming is because they don't like math. Don't worry, we're actually going to use programming to not have to do math. And the way that we're going to do that is we're going to solve this in a programmatic way and put on a different type of hat, right? So usually when you first try to solve this, you had this analytical hat on, maybe a mathematical hat on when you try to solve it. And now we're going to try to look at this in terms of a computer in a computational way. So rather than actually solving anything using algebra, we're going to think, what is another way that we could solve this problem? And it might have been the first way that you might have thought about when you try to solve it. The approach we're going to take throughout this whole section is going to be a guess and check approach. What we wanted to know, to reiterate, is at what points is this equation here going to be equal to 0? So what numbers do I plug in for hours of math to make this 0? That's these points, these roots, right? Where is this going to be 0? Is the question. Now, what we're going to try to do is we're going to use this guess and check method. Basically, we're going to plug in a whole bunch of different numbers for hours of math until we get 0. And then that's going to be one of the roots of the equation, right? This is the approach we're going to take to try to solve this problem. And this might be the most intuitive approach to take if we don't know anything about algebra and we don't know how to solve this ourselves. For instance, I can just try random numbers. So if I just tried 4 hours of math and plug it in, right? I get 4 squared minus 3 times 4 for this equation, and I end up with 4. That's not 0, so I'm going to have to try something else. I try 5. I put in 5 into the equation. I get 10. I actually went in the wrong direction, so maybe I should go the other way. I use 3, plug in 3, and viola, I end up with 0. So basically, this is me manually doing exactly what I just described. I try to plug in a number for hours of math, and I'm trying to get this to be 0. And if it's not 0, I just try another number until I get 0. Another thing that might be obvious, this one isn't the hardest one to solve. If you plugged in 0 for hours of math, you get 0 squared minus 3 times 0, and you end up with 0. So those are the two roots, right? We found the two roots of this quadratic equation, right? Just by trying out a bunch of numbers. We tried 4, we tried 5, we tried 3, and we got 0. And then we could keep trying numbers. If we plugged in 0, we'd get 0 too. So those are the two roots. We know that there's at most two roots. So that's it. We figured out the roots of this equation, and we didn't have to use some crazy long formula to do it, which is great. And this might have been the way that you tried to solve it yourself if you didn't know the quadratic formula, right? But there's a little bit of a problem with this method, and the problem is mostly in computation. We know that this will work if we just keep trying out numbers and we get a 0. That will work. But imagine if it was a little bit harder to just try different numbers like this one, right? So here we have hours of math squared minus 4 times hours of math plus 7 over 4. It's still in the same form. We have a squared term, we have a regular term, and a constant term here. But it doesn't quite work out the same way because this is going to be a little bit harder to find. You can imagine that this doesn't have to be an integer, right? It doesn't have to be a counting number. It doesn't be 3 or 2. It could be 7.5 or 4 and a quarter, right? We don't know exactly what that number is. So that's part of the difficulty. And it's going to just take a lot more guessing, right? So this one is maybe not as straightforward to solve. The problem isn't really in the methodology, right? Our methodology, we could do a similar thing here. We could just keep trying numbers, keep guessing, keep checking. The problem is more in the practically, like we can't just try all these numbers. We can't, but a computer can. So this is the general idea of this problem and how we're going to try to solve it. The first thing we're going to do next time is we're going to try to dig into this a little bit with a computer. So rather than writing all this out, we're going to use the computer to try to get to this answer for us a little bit more easily. Great. So this is the problem statement. I hope this all makes sense. Next video, we're going to jump right in. We're going to start programming.